Hello everyone, this is LeetCode problem number 1 to sum. I'm going to be using Python. So, given an array of integers, nums, and an integer target, return the two indices of the two numbers such that they add up to target. So for example, we're given a target and we have to find two numbers that add up to 9, that'd be 2 and 7. We have to return the index, so it would be 1 and 0 and 1. That'd be our output, right? Likewise here, we have target of 6. We need to return what two numbers add up to 6. That'd be 2 and 4. So the index here would be 1, the index here would be 2, and that'd be our output. Now, we may assume that each input has one solution and they cannot use the same element twice. That's why, for example, for this problem, this example 2, that's why we're not returning 0 and 0, because 3 and 3 does add up to 6, but you can't use an index more than 1 when you're returning. So, hope that makes sense. Now here, 3 and 3 does add up to 6, but see how they have a different index? That's why it's acceptable in this example. So generally people who are new to LeetCode tend to approach this problem using nested loops. That has certain problems with it, mainly because the input array nums.length, it can grow pretty large, right, for a given test case. And, comparing, this element against all these to see if we reach our target, comparing this element against all these to see if we reach our target, that's problematic with a large input array. It's not optimal. So there are different approaches that are more optimal, one of which is a hash map. Now, basically, the way you approach this problem with a hash map is, first of all, let's just basically outline the simple things about a hash map. So hash map has a key and a value. Now, if you have a given array and for some reason you're storing it in a hash map, generally you store the index of that array as keys in the hash map, and the elements in the array you generally store as values in the hash map. But for this problem, you don't want to do that. I'll show you why. So first of all, let's just get to the problem at hand, right? We have two problems, or we have two numbers, a plus b, and they add up to the target. Now we can rewrite this as target minus b equals to a. So as we iterate through this, we can basically check 9 minus 2 is equal to 7. Have we encountered a 7 already? No, not yet. 9 minus 7, that is 2. Have we encountered a 2 already? Yes, we have. So that's how we know that we have to return these two indices. That's much more optimal than a nested loop, right? Because you're not doing these like nested comparisons that can get really crazy. And so that's why a hash map is more optimal. And so because we're taking 9 minus whatever element we're on, and we're seeing if that is equal to something we've encountered before, that's why rewriting a plus b equals target as target minus b equals a, or if it is equal to a, checking if it's equal to a. That's why this is pretty useful. Now, again, remember what I said earlier about hash maps and how generally we store arrays in hash maps? There's a particular keyword in hash map called in, or a keyword that you can use for hash maps called in, right? Like, for example, 5 in hash map. Now, what does 5 in hash map do? 5 in hash map basically checks if there exists a key, which is 5, in the hash map. 5 in hash map does not check if there's a value in the hash map that is 5. That's not what it does. What it does is it checks if there's a key that is 5 in the hash map. That's why for this specific problem, it's much easier and much more simple to store the actual numbers as keys in the hash map, not as values in the hash map, but as keys. Because because when we store them as keys, we can do the comparison 9 minus 7, right? That'd be 2. Is 2 in the hash map? Well, yes, it is. 2 is in the hash map. And again, this is checking if 2 is a key. That's why storing these numbers in the array as keys is much more easy for this particular example or this particular problem. And it really simplifies the entire problem of, or the entire process of using a hash map in this particular problem. So, and this will be in O of n solution. We'll talk about that a little bit after we write our solution. So first of all, we need to obviously establish a hash map. So we're going to create a hash map called hmap. We're going to iterate through our list of numbers. And again, we care about the numbers, 2, 7, 11, 15. We care about those numbers. So we are going to retrieve the element, but we also care about the index because that has to be our output. So we do care about both. Okay. Now, again, remember what I said. Instead of a plus b, is that equal to target? We can do target minus b is equal to a. So target minus b. And remember that b in that example I gave, that is the current element we're on right now. So does target minus the current element we're on, that's going to give us some number. Is that resulting number in our hash map, right? This is checking. Like, for example, if the target, this would be like, let's say we're on the 7. We're iterating through this list. We're on the 7. Does 9 minus 7, that would be 2. If 2 is in our hash map, which it is, then we have to do something. Well, if 2 is in our hash map, then we know that we already have the 2 elements that we need. So at this point, we're going to actually return the indices that we need. So we're going to return. And because we're storing the actual values as keys, or because we're storing the actual elements as keys in the hash map, what would be our values in the hash map? That'd be the indexes, right? So when we do target hmap target minus element, that would be 1 index, and then the current index we're on. All right, because remember, this is 2. This would be 2. So hmap target minus element, that would return 0. It would return the index of this. And the current, and then here is the current index we're on, which would be the index of 7. That'd be 1. And so this would work just like that. But we also need to handle our other case where, for example, if this 7 was over here and we were on 11, is 2 plus 11 equal to 9? No, of course not. So in that case, we would basically need to add 11 as a key to our hash map, right? We would need to add 11 as a key to our hash map and the index of 11 as the actual value in the hash map. So we do hmap. The element, again, has to be a key, and the index has to be the value, just like that. Now, if I run this, it should work just fine. Yeah. So this is pretty optimal solution. And I know there's like, there's a few approaches to this problem. So, if you did something else, it's probably fine as long as you're, taking into account, the constraint of really large numbers or really large lists, because that can be problematic. So I like this problem because it's very straightforward, or rather the solution is very straightforward and it's very easy to remember if it ever shows up in an interview or something. Yeah, very simple. Just one for loop and an if and an else. Basically all it is. And as long as you kind of understand how to approach the problem, you don't even really need to memorize the solution. Just intuitively, it'll make sense to you. And so that's why it's important to kind of visualize the problem mentally, rather than just memorizing the code. So I hope this explanation has helped you. If it has, then, leave a like, and subscribe. Give me a comment. Tell me if you have a different solution that you like. And there are like shorter solutions. I know people on LeetCode sometimes write like really, really, really short solutions, but this is a balance between something that is simple but also readable. So I hope it helped you if you are looking for a solution, and I hope my explanation helped you because when I first came across this problem, uh, some of the explanations that I came across were not so helpful. So I hope this helps clear the problem up for anybody who needs it. All right, thanks and take care.